Okay, I'm back, and now we want to begin by talking about what energy is. So, notice the abbreviation for the concept of energy is going to be the letter E. And then the official metric unit for energy is going to be called the joule. And then that is going to be abbreviated with a capital J. So, let's talk about what energy is. Well, that's kind of difficult to say because in your textbook they say energy is the ability to do work. Well, in order to define that, we got to know what work is. And then later in this lesson, we will define what work is. I like to think, though, in terms of what does energy do instead of what is energy. So you should know that if you put gasoline or petrol into the gas tank of your car and then you turn the ignition, what can it do to the wheels? So the wheels are initially stationary, but then when you apply energy to the wheels, they begin to turn. So notice that there's a change in the position of the wheels. They're changing now. So at first they're not changing, but now they are changing. They're rolling. Okay, another thing is let's say that you have a bowling ball, and that bowling ball is rolling in a certain direction. And now let's say that you want to change the direction that that bowling ball is going in. Well, you could hit it with another bowling ball, but you're going to have to give energy to that bowling ball so that it will roll into the other bowling ball and then cause that bowling ball to change the direction it's moving in. And then another thing might be, let's say you've got a tin can and you want to crush the tin can. Well, you have to squeeze it. So you have to put energy into the tin can in order to change its shape. So do you remember that there were three different things that a force could do? A force could change the speed of something or cause it to accelerate. A force could change the direction of something, and then a force could also change the shape of something. Well, all of this is going to require energy. So you're going to put energy into the system in order to cause the system to change. Now, what are some different kinds of energy? So that's what this picture here is showing. And in this course, we're not really going to deal with all of these different kinds of energy. So like the first example is, what about chemical energy? Well, you know that in order for your body to be able to function, you got to eat. Okay, and when you eat, there are chemical reactions that are taking place in your stomach that are going to release the nutrients, which then gives energy to your body. So those are chemical reactions. When a stick of dynamite explodes, it gives off energy because of chemical reactions. Now, are we going to deal with that in this course? No. So that's chemistry. Okay, well, what about electrical energy? Yes, we already discussed that. So in a previous lesson, we talked about, for example, a capacitor, which stored electrical charge. It stored electrical energy. We talked about the inductor, and we said that it stored magnetism. So it stored magnetic energy. And then we talked about what lightning could do. We talked about what voltage could do. And voltage was related to the amount of energy in the system. So there's lots of different kinds of electrical energy. What about light? Well, we already covered that as well. So when we talked about waves, we talked about electromagnetic radiation. And so that was what? Radio, infrared, visible, ultraviolet, X-ray, and then gamma rays. So all of those were different kinds of light, and each of those different kinds of light had a certain amount of energy associated with it. So you know that if you go outside, you can get a sunburn, and that's because of ultraviolet light basically cooking your skin, and it's burning your skin off. And you know that if you're Bruce Banner and you get a lot of gamma rays, then you turn into the Incredible Hulk. Okay, so gamma rays have a lot of energy. Okay, what about thermal energy? So you should know that it takes energy to turn an ice cube into liquid water. Also, you should know that when you have hot soup, that soup contains a lot of heat energy, and then if you set it on a table, it eventually cools to room temperature because it's giving off that heat energy into the room. Now, are we going to do much with it? No. So you would learn about that in chemistry. Okay, then you've got mechanical energy. And so there are two kinds of mechanical energy: potential energy and then kinetic energy. Are we going to do anything with that? Yes. So we're going to do a lot with potential and kinetic energy. And then you've got nuclear energy. And so there are two kinds of nuclear energy: nuclear fusion, which is what the sun does. So the sun is fusing hydrogen and turning it into helium. And in the process, that's giving off tremendous amounts of energy. And then you've got nuclear fission, which is what happens when you've got a large sample of radioactive substance, and then it spontaneously breaks apart into two smaller chunks of radioactive substance. So that's going to be called nuclear fission. And then you can see there, that's a picture of the power plant in the cartoon The Simpsons. So later in the course, we will get to nuclear power and we'll figure out exactly how does it do it. Okay? So in case you're interested, here are some typical energies in terms of joules. So that shows you just how large energies can be and how small that they can be. All right, let's take a break. When we come back, we're going to start to talk about mechanical energy.